Hello ladies and gentlemen, upon request from one of my old friends Sainath Patil, I am making this webinar on the new domain Internet of Things for you. I am Vikas Thombre, a product development expert with 20 years of diversified experience in the domains of software, hardware, product development, IoTG product development, integrated circuit test software development, component and product testing. I worked on various validations and verification tests. I also have experience of working in production environment or making the production environment ready for the newly developed product. I have worked also in sales and marketing, component as well as product sales, pre-sales. I think in your educational curriculum you would have studied this topic of Internet of Things. Somebody would have taught you or you would have referred some YouTube videos. There are very nice videos out there in YouTube. Today in this webinar I am focusing mostly on the practical scenarios of Internet of Things so that you will be aware of variety of domains of this Internet of Things you can apply. Also, I will be focusing on how worldwide organizations observe this particular IoT domain, on what parameters they define their investment in this domain. So if you know this, you can able to select this domain as your starting career. You can develop the strength of various stages of this particular domain. Webinar outline, we will see the current situation in the world, what, why and hows of IoT. I'll take you through various examples of IoT in various domains. Then we'll look advantages and disadvantages of IoT. Constants, which is very important point which you need to take care in the beginning of the requirement definition. This is very important. Why? Because it will not give any last moment surprises once your product is ready that you haven't considered this point, no, you was not aware of that. And then I'll propose you so-called design approach, how your design approach should be in order to design any product. So what is the current situation today? All over the world, billions of objects are already interacting and sharing information, such as cars and smartphones. Things are increasingly becoming an active part of Internet. So the picture on right shows the status of the future city wherein all the things will be connected to each other and they are communicating. There is no human involvement here. The systems are designed to send the data, take the required data and send it to the cloud, and human can check the required data on their smartphone or on their PCs whenever they want by using the internet. Then how this is possible? Everything in the world can transmit the data to web and communicate with every other thing in order to perform a variety of tasks for its owner. How is that possible? On the Internet of Things, the physical and virtual worlds are fused. So what is IoT? Connecting things to the internet yields many amazing benefits. We have all seen these benefits in our smartphones, laptops and tablets. But this is true for everything else too. The Internet of Things is actually a pretty simple concept. It means taking all the things in the world and connecting them together. In a nutshell, The Internet of Things is a concept of connecting any device so long as it has an on-off switch to the Internet and to other connected devices for new value creation. What is this new value creation? If you do something, if you design some system, and if this system doesn't solve any pain area of the end user, then there is no value. Then there is no interest for others or customers or users to buy your system. So whatever you do with the Internet of Things, it should be able to solve some pain areas or the needs of the customers. It should have some must have in it which is not taken care by any of the similar system as of today in the world. The IoT is a giant network of connected things and people, all of which collect and share the data about the way they are used and about the environment around them. So why Internet of Things? So let's compare the example of traditional system as compared to the today's smart IoT systems. So I'm taking two examples here, how the situation in former times and how the situation with the IoT systems today. So first example is a municipal corporation. In the traditional era, municipal corporation, how it was working. All of a sudden they used to discover, oh, air pollution is suddenly increased in their area. So this used to fire question in their mind, why and where it is increased and what should we do to control it. The actions used to start when the event has already been triggered. How the today's smart system works here. Air pollution will be increased in next week due to the increase in PM 2.5 and PM 10. Particulate matter 2.5 and particulate matter 10. These are the size of the dust particles in the air. And why this will happen? Because there is a mall construction is planned in RT Nagar. So in order to avoid this, they already know that they have to instruct the mall construction team to use the dust screens while starting their construction. So here in a smart municipal corporation, they already know that there will be increase of particle count because of the mall construction, and they know what they need to do. Second example I'm taking is a maintenance technician and how maintenance used to happen in the organizations or the industries in former times and in today's smart world of IoT. 17 machines under breakdown today. So there was no intimation to anybody that 17 machines are going to break down today. Till yesterday nobody was knowing. Why all at a time? Do we have enough space in our hand to repair those 17 systems? I have only one technician per shift. So to repair 17 systems, I might need to break down my production for several shifts. How much will be the breakdown time in total? How much breakdown time will be and how much production time I will lose? How this is when the smart system is in place? They already know 2 machines are scheduled to be maintained with planned production shutdown. So with the smart system, they already know that there is a problem in the 2 machines, and before they get breakdown, they are been scheduled to maintain. So since conveyor will break down, so they already know the conveyor is getting weird, the conveyor will work for next 15 days, so we need to maintain the conveyor within a 1 week time, so that keeping 1 week buffer, we will not have unexpected surprise breakdown on our production, and production will not stop. So for that, spares are already scheduled. The one technician is assigned to repair this conveyor, and two lines will break down serially 1 hour each in order to repair this conveyor. So the production can be planned in such a way that there will be 2 hours of breakdown without any loss. Yes, it's time for world to become smart with usage of IoT technologies. I hope the next symbol remember you, James Bond. You might be remembering the smart remote operated car, which is the actual car James Bond used to drive. This is no more dream today. We can do much more things than this. How Internet of Things is implemented. Here in this slide we'll see how the IoT system looks like. So vision of end-to-end IoT system. So we'll see the building blocks of IoT system. There are 6 various building blocks of IoT system. The first block is called things. What are things? Things are nothing but the uniquely identified domains or node. So to design any system, you need to identify the domain where there is an imminent need to take care of certain things, wherein you can design a system to take care of such things. So you should know what exactly is missing there, what exactly is the pain area of the user there, what are their must have, what are their good to have features, what are they expecting, which is not taken care by existing systems in the world. Here, if you find the things matching this expectation, then you have a possibility to design IoT system which can get scalable in future if it can really resolving the needs what you are designing the system for. The next stage of the IoT system is called sensors. Sensors are nothing but the communication or communication medium without human interaction with connectivity. Now don't go on the name as it is sensors. So I don't mean here it is a pressure sensor, temperature sensor only. When it is referred as a sensor, it is a sensor, pressure sensor or temperature sensor combined with conditioning circuitry, including the processing power and connectivity and memory. So sensor will read the physical parameter, convert it to the electrical parameter. The conditioning system will try to condition it so that it can be directly read by controller with the help of software, and it can be stored in the buffer memory of this system. This particular sensor system will have a limited buffer memory because you cannot afford to add very high storage of memory here. It will be costly because you normally need many sensor node in the practical environment, and the sensor system will have a connectivity to the cloud directly via internet or to the nearest gateway. So next stage here is the IoT gateway. IoT gateway is nothing but the simple router which will connect to your system over Wi-Fi, and the sensor themselves can directly pass the data to the cloud. Or otherwise, on the broader way, IoT gateway can be a full-fledged design system which has connectivity, safety implemented, security and safety implemented in it, so that the data will be encrypted before passing on to the cloud, and it will have several interfaces with which it will get connected to the sensors. So it can be connected over Wi-Fi, it can be connected over Zigbee, it can be connected over Bluetooth, and this will pass the data to the cloud. So the definition is IoT gateway provides the needed connectivity, security and manageability. So manageability is nothing but, for example, you do not have internet for 1 month period of time because of some breakdown issue, and you install sensors, and sensor has only limited buffer, so it can store only 1 hour of data, but you need to maintain for 1 month. So gateway can help you here, because gateway can give you facility to connect external hard disk which can be of any capacity, and you can store a month or 6 months of data into this system, and whenever the internet is available, gateway will push this data over the period to the cloud. So data is not lost here. So that's the advantage of gateway, and that's the need of the gateway. The next stage is cloud. So what exactly is cloud? Everybody is talking in today's date cloud. What exactly is cloud? Cloud is nothing but the large pool of virtualized servers and storage that are networked together with computing and analytical capability. Now this is just a definition, but to explain you more, there are certain cloud providers companies in the world. For example, Amazon Cloud, Microsoft Azure Cloud. There are many other companies which provides cloud. Now what this company does, this company have a huge capacity servers which has both computing and analytical power, and these servers are installed worldwide at several locations, and then these servers are connected to the internet, and end users who design their IoT system want to use the cloud. They purchase this particular cloud capacity depending on their needs, that okay, you need only capacity of 10 GB per month, and you need computing power of processor 2 gigahertz and not more, and you need 2 core processor. So you need to pay for this infrastructure as well as the amount of use your system or your sensors are doing per month. So you need to pay that much amount to the cloud. So you go to the cloud site and you can see these rates, and depending on they will have several plans. So you need to check what is your capacity, what capacity you need, and you need to select a right segregated rate and the plan, so that you will not pay in extra. The next stage of IoT system is IoT application. How end user will know? It's actual medium of interaction with user or customer, that is a software running either on the PC or on the mobile. So this software is designed in order to show you the data in the form whatever end user want to see. For example, the operator want to see a detailed level of machine statistic and the machine functional characteristics on very minor level, but management doesn't want to see individual machine characteristics, but management only want to see how many machines are breakdown in 1 week, what was the maintenance time, what was the breakdown time. So if they get that graph, that is fine. So software is configured depending on the requirement of the user. There are many customers, there are many users of your system, and every user have different expectations. So depending on their individual user ID, those features are given to them. So some of the features are only management specific, those cannot be accessed by user, and some of the features are only user specific, those cannot be accessed by management. The last and very important stage is customer. Who is customer? Customer is nothing but an individual or entity who will buy this product or service from you. Now you will ask me, how come a customer can be a part of this system? It is not a part of system, right? Customer is extra entity. Yes, it is extra entity, you are right, but it is very important to connect a customer also as a one part of this IoT system, because you really need to take the inputs from customer before designing this IoT system. You should not end up in designing the system just because you know how to design it, but it should also provide some value to the customer. That means it should solve pain areas, it should solve their real problems, and then only this customer will be interested in buying your system. So customer is very valuable part of the system which need to be always thought of, and the requirement from customer should have been taken very first time in your requirement specification for your system, so that you will not find surprises after system is ready. So applications of IoT. In this slide we will go through maximum domains and their examples, what one can build. So the first domain is B2C consumer set of domains. B2C is nothing but business to customers. So it is that business which is delivering directly to the customer. First domain is a smart home. Example of smart home is you can build smart elevators in your house, or you can build with the help of IoT automatic lighting control. So in the home, when there is a less light available than certain lux, you can automatically turn on the lights in the hall. Or you can also take an input from proximity sensor when the man enters into the bedroom, or when the person enters into the bedroom, his proximity gets detected, and depending on the light availability, decision can be taken whether to turn on the light automatically or not. Or when the person opens his cupboard, even the smart system can be fit inside a cupboard, that the moment the door is open, the light inside the cupboard is turned on. So such systems can be developed under smart home domain. The next domain what we are seeing is smart appliances. So what can be example of smart appliances is like smart heaters or smart washing machines, smart refrigerators. You can have in future smart cookers. What smart heater will do is nothing but it will give you a chance to program when you need to heat the water, so you no need to get up half an hour early to turn on the heater and then wait till the water becomes hot. Smart heater will take care of this requirement. Once you program every day, it will be starting your heater at 5 o'clock, and by 5:30 the hot water is ready when you get up for your bath. So the next domain is elderly care. Elderly care domain examples are you can think of kind of smart pulse measurement or BP control or emergency alert systems. Here sensor can read the pulse, and depending on the pulse frequency increase and decrease, the continuous monitoring can be done, and it can be whenever this particular elderly person's needs the service can be defined, or during the unexpected situations direct call can be made to their doctors, personal doctors, for immediate service. Before the elderly person notifies that, oh, his pulse is low or he's trying to get some feet or something, the machine itself will take this measurement and beforehand call to the doctor, and doctor will be ready to support him. Wearable gadgets. I think this is not new for all of us today. There are many people wearing the smart watches on their hand, which help them to detect their sport activities, their sleep parameters, deep sleep timings. It can also detect your pulses, and it gives you very good characteristics how are you exercising your body, how much calories you are burning a day. So this is very helpful. So something can be thought of. So there are some wearable helmets coming up with which can able to guide you for the path when you are driving the bike. The helmet will guide you on how after how many meters you have to take left and right. Just helmet will communicate to your mobile Google Map application and try to uh, make a sound and intimate you what to do next. Or another example, smart glasses. Smart glasses can show you a picture on the small frame left or right side of your glass when you have to take left turn, how much meter after you have to take a left or right turn. So the next set of domains is industry and farming. The first domain in industry and farming is smart manufacturing. I think we have taken example of smart manufacturing in my earlier slide. It's maintenance, smart maintenance, wherein smart maintenance system already knows wear and tear percentage of the machine and when the machine is going to go break down in future, how much time beforehand the maintenance activity for that machine should be done, and that way a plan can be made for the efforts or for the spares needed to maintain that machine. Smart agriculture. This is another domain. I can think of some examples wherein you can install the sensors in your farm soil. These sensors will detect the humidity percentage in the soil, and depending on the water levels, watering of the crops can be scheduled. So you no need to water the crops if the soil is already humid. That way you can save a lot of water. Whenever you need, you give. If in the summer you may need to give more time, but in winter you may not need to give every time the water. Intelligence maintenance. Yeah, I think this is one of the example we took. Intelligence maintenance. Inventory management is another domain wherein you can manage, you can track the items in your company or in your shop. You can see in many malls the costly items are attached with some tag, RF tag. This RF tag helps them to track the inventory, how much percentage of this particular items are available, how much percent is sold, how much percent is stolen. Definitely nothing will get stolen because there is a detection available at the gate. If you don't pay for the item and you are taking that item out, immediately the system reads that item and checks for the payment, and if the payment has not been done, it will make a sound which will notify the security that you are taking something which is not billed. So the next set of domains is infrastructure. First domain is a smart city. So the example of smart city, you can design a smart light control IoTG system or smart surveillance system or traffic control, waste bin management, theft control, security control. All these systems can be done with the help of IoTG technology. Just an example of traffic control, you can have a smart cameras attached on the traffic signal, and these cameras can able to track which vehicle is crossing the limit line and crossing the red signal, and you can take the associated video clip of that vehicle with the number and the driver's face visible, and you can automatically generate these invoices to such criminals. You can send the invoices to their home and they cannot deny paying this payment because they have broke the signal. That way a control, a well needed control can be established. It's just the systems are already ready. We have designed such systems. It's just a decision from government when they can afford such systems and when they can manage to install such systems and how many signals they want the system. So next set of domain is smart energy and utilities. The example here is smart power grid system, wherein kind of IoT system can be designed to detect the appliances in your home or in your small organization factory which are taking more current because of the maintenance needs, and then you can determine from the statistic that your machine is taking more load, more current, so you may need to maintain, or oiling requirements are there, so you can maintain the machine so that it will run smoothly and take less energy from the grid. So smart system can only able to give such alerts to the end users. The next domain is environmental monitoring. This is one of the very peaking domain in today's smart city environment. We are seeing that the air quality is getting degraded, and it is very much needed to detect the hazardous substances in the air, so hazardous gases in the air, and the dust particle. So this can be detected with the help of some sensors like gas sensors, or particulate sensors, or sound sensors, light sensors can be used in such system to detect such parameters and pass on the data to cloud or to the website, and anybody can open the website and see what is the situation at this chowk of this city on this day and which hour. All this thing is possible only with the help of IoT system. The next set of domain is commercial domains like medical healthcare. Small example which I can quote immediately is the non-invasive devices which are very much popular nowadays. Uh, Former times we used to take out the blood to detect the jaundice in the babies. It's very petty job to take out the blood from 1 year old, one day old baby. It's very difficult, and sometimes you cannot find the nerve of the 1 day born baby, and you need to pick the baby many times. Current smart systems which are non-invasive, they no need to take the blood out to measure the jaundice, but simply by scanning the skin of the baby you can able to read that particular parameter from the blood, and they can able to tell you, these machines can able to tell you whether the jaundice is there or not, or at what level of jaundice is there, whether the baby need to be served immediately, or baby can survive without immediate medication, or the medication is effective positively, or medication need to be, dosage need to be increased. All these things can be decided based on the smart non-invasive systems readings. You don't need to pick the babies. The next domain is transportation domain. I think I have quoted the example that the companies who transport their shipment which are really environment sensitive, wherein the shipment need to be maintained under certain temperature humidity requirement. Once the shipment leaves the company doesn't have control on the environment of the shipment, and the shipment provider is responsible for that. So company can use some smart sensors to detect this environment and record the continuous real-time data of environment from the day the shipment left from the company's door and enter into the destination. So all the data second-wise can be measured and trapped, and this can be sent to the cloud, and any responsible person can monitor the shipment parameters at any time from their mobile. It is possible. So this is possible only because of the IoT system. The next domain is a building automation. Uh, Building automation, I can give example of smart elevator management, wherein the maintenance needs for the elevators or the energy consumption can be detected with the help of such smart systems based on IoTG, or smart parking or smart yard, kind of another example of building automation system wherein you can use IoTG technology. So it's just the idea which you need to develop, which idea where the IoTG system can be developed, and then you need to check with the end users if such system, if at all it is designed, will be helpful for them, whether they will buy such system, and if they want to buy such system, what else they expect from this system. You can collect such requirements from your future users and focus on such features development. And if you can do these things, I think you can develop a scalable IoT product. Here we will go through the advantages and disadvantages of IoTG systems. So advantages: efficiency in using the things. That means I have given an example of smart water management system for the farms. So here, depending on the soil humidity, depending on the water presence in the soil, the watering requirement is derived, and watering is done to the plants only when it is needed, and that way we can use the water efficiently. Efficiency in industry is another example wherein with the smart maintenance system you can avoid surprise breakdown in the industry, you can avoid major breakdowns, you can take care of the breakdowns smartly well before the machine failures happen, and this way we can increase the efficiency of the production and the reduction in the waste. Saving time. IoT system helps to save time because the periodic data is collected by the system and direct trends are possible to generate, and from those trends conclusions can be derived and time can be saved. Saving of money: if your breakdown is less, you will save money. If you are taking more energy, you will pay more. If you will save your energy, you will end up in paying less money. You can do smart monitoring. So like traditional era, every machine used to be maintained at predefined frequency. For example, every machine maintenance frequency may be defined like 3 months once this machine need to be maintained. Then no matter whether the machine is running fine or machine is not running fine, the maintenance person will go there and do the planned job. Smart monitoring system with the help of IoTG brings the need of maintaining the system whenever only it is needing the maintenance. So the machines which doesn't need maintenance is not given to those machines. The disadvantages of IoT system is the privacy implications. You need to spend additionally for security of your data which is passed to the cloud. You need to encrypt that data every time, and this requires extra hardware or extra software development resources. That way it is not seen as a positive for IoT. Autonomy and control concerns. This is how to control the parameters once you see the data in front of you, a data continuous real-time data. You need to know that data can be transformed into the trends, which is useful for deriving the useful insights and then take actions. So this is This comes with experience, and in the beginning when you design such system you may face some difficulty, but over the period, once you are uh, experienced with such data, you can able to find a cycle here. Data storage is always a challenge because every sensor is deriving certain number of data points every second depending on the severity, and the data collected for IoT system is in huge, and for such huge data you need mass storage. So data storage is seen as one of the concern. Security and safety, yes, as I explained, when you are sending the data to the cloud, it is to the internet, and if it is not adequately encrypted, some hackers can decrypt the data and the company confidential data may go out. This is not so easy. You can definitely protect it, but yes, there are some hackers. They can do the job. Environmental impact on the electronic devices is also a drawback. I can give the example here. For example, you have designed a IoTG smart monitoring system, and you have sold the device to government, and government install such systems on the several cities and several states of the India, or it is distributed over the worldwide. Now the environmental characteristics impacting on such system is not same in every place of the world, but the system is designed by considering same boundary conditions. Here you might face some challenges where the places where the temperature is very high, or the humidity is very high, or the uh, dust particles are high, sand flowing is high, you may face problem of sensor blockage. Sensor Once the sensor is blocked, the reading will get deviated. You may need to clean those sensors, so you may need to have servicing parties who can regularly, periodically go and maintain your sensors in order to get the accurate data. All these are the things which you need to jot down in the beginning of the product development, and then work on it over the period. So at last, it is finding perfect balance defines the time to success. So you need to really find the balance between all these points and take care of both the balance this point. You need to take care of all the affecting parameters, and if you're taking care of those, then there is no problems ahead. Constants in IoTG systems. So what constants you need to take care from the beginning, or thought of from the beginning, from the time of requirement specification. We will see it here, all those constant important constants. The major goal in IoT is to take the data securely to the right place at right time in right format. So let us consider some practical challenges. So constants challenges is one and the same things, and success is very much dependent on this constant. How efficiently you manage such challenges and constants. Continuous evolving technologies in IoT. Here, the technologies like Bluetooth, Wi-Fi, Zigbee. Every time there is a new technology, you should be thinking of designing IoT system and completing your design and putting this IoT system into the market at right time. If you have delayed in designing and testing your IoT system, and the next technology is out, it's very difficult to get the expected revenue out of your system. Furthermore, you may find challenges in supporting infrastructure if your technology is way old. So this can be a challenge. Complex and non-evident IoT piracy concern. So as we talked in the previous slide, the data from the sensors are directly put up into the cloud, and cloud is maintained by common platforms in the world, and it's outside your company, and the company confidential data is going outside your company. So this data need to be encrypted. Sufficient security protocols should be used to encrypt the data, and this adds additional expense. So you need to really think of adequate security for your data in order to protect it from being hacked or pirated. Limited experience of life cycle management. So this can be a challenge. IoT being a new emerging field, not every company is successful in putting IoT products into the market. All companies are experiencing IoT domain, and they are making their products and they are putting the product into the market, but they haven't seen complete life cycle of the product. That means the product is designed, tested and sold to the customer, but there might be some problems, and companies are taking care of those problems under their AMCs. So there is no complete okay IoT product, because this is continuous learning domain and new domain. The open points are need to be recorded and need to be taken care of in the next sample design. Lack of related standard. So since IoT is a new technology, you may not find the international standards for reference for every technology. It is relating to data, and when there is a data comparison, data accuracy, very less standards speak more about this. How you do the correlation of the data. That means the challenge today is there are 10 firms which is making temperature monitoring machine, and all the 10 machines measures the temperature, but all the 10 machine gives different data. All the 10 doesn't give the same number of the temperature count read at the same place. So which one is correct? In this scenario, the correlation need to be done with reference to the standard defined, and these standards are missing. Everybody follows their own standard and they design the system, but international one standard, unique standard is missing. That's what is a point here. Supporting infrastructure. For example, you design a IoT system which is GSM based. So your device has a SIM card which is having a data, and you are trying to push the data from the sensor to the cloud via GSM technology. And GSM technology sometimes have drawback, because not every place in the city or in the country you get the same speed, and if the speed is low, sometimes the network is not available, sometimes networks get disconnected. In such scenarios, your data loss possibilities will be high, and this need to be taken care in your design. You need to pre-think of all possible challenges which you will face with reference to this while deriving the requirements, so that it will be taken care in the design. Diverse protocols and conflicting configurations. So you have n number of protocols for the data transfer, for the networking, for the interfaces which is there for the sensors. And sometimes you may end up selling a sensor to the customer, and customer want to use that sensor with their own internal system, and both this system conflicts in the protocol, because you use one protocol, the company system which is way old uses old protocol, and now there is a conflict between this protocol. So you may need to work additionally to solve this conflicting situation. You need to write a software to take care of this conflicting configurations and find out the workaround. So this is a challenge. So you should know your customers well in order to design the system. If you miss your customers, then you may end up in such problem. Complicated IoT security. Since there are common handful of technologies, security technologies available, everybody knows these technologies, how you secure your data, how you encrypt your data. And the other side of it is people can decrypt that data with the same technology. So security is a big concern, and you need to use a complicated algorithms to really protect your data from being hacked. Networking issues, network traffic, data buffering. Since this is related to a huge amount of data which need to be passed on to the cloud, networking plays a very important role here. If your data is passed on the network, and if your network doesn't have enough speed to pass on the data points which are needed, say for example you need 500 data point capture in 1 second, that calculate how much data point you will be sending in 1 minute and 1 hour. Those many data points, to pass those data points to the cloud, your network speed should be sufficient, your internet data speed should be sufficient. If this is not matching, you may end up in losing the data. You may not try to get the trend which will give you the real failure scenario what you are expecting, just because there is a conflict between the network speed and the network speed which you design your sensor for. Maintaining same energy levels with the distributor. So once your system is ready in certain company, you alone cannot handle the distribution of that product everywhere in the country or everywhere in the world. You may need to tie up with the channel partners and distributors to advertise your product with their own networks which they have already found. And when you identify such distributors, they will be with a very high synergy level in the beginning in order to get associated with your product, and depending on the interest in the market, depending on the sale quantities into the market, the synergy level moves from high to low and low to high for this distributor. And in order to sell your product in quantities, you need to keep the synergy levels of these distributors, and you need to define certain strategies in order to attract your customers together with your distributors in order to maintain your sales. Power issues. As you know, IoT devices are having sensor node which are very small and can be fitted remotely at certain location in the company or at certain place in the city which is at remote area. You may not have power at that place. You may not have 230 volt wherein you can use a power cord there, and such sensors need to be designed with the battery power. Battery power is limited, it has an end after certain duration. It depends on how efficient your system is designed, the battery will give the longer life. So power issues are always there, and you cannot overcome these issues for all the customers. So if you really know your actual customers for which you are designing the system, you can make your system compatible with your actual customers. And there is no actual customers that anybody can become your customer and they can come up with a very huge order, but they will have certain scenarios wherein your sensor will fail for the power issues. So always you need to think about the customer and customer environment before designing the system. Storage issues. Some parameters need to be recorded at very low frequency. For sure it will be not needed to be recorded at high frequency, but some parameters are really needed to be recorded at very high frequencies, 1000 data points in a second. This will call for huge storage requirement on board with the sensor and or otherwise very high speed internet to push the data to the cloud. It will be high amount of data. So these issues will be there. So you need to know which particular location you are trying to install your sensor, whether that location supports high connectivity internet or whether that location supports GSM. What is your limitation with the system if you want to install in that location your IoT system. All these things need to be studied in the beginning, and then you need to compute on the storage requirement before designing the system. Congestion and overload issues. This is always present in the networking systems. So you need to take care of such issues in the software development by developing the software efficiently to avoid congestions. Addressing and sensing issues. As I mentioned, not every place on the planet has same environmental conditions. So you don't know what environmental parameter is your enemy at which place. So you need to really consider all aspects, all loads, all environmental loads which are acting on your sensor and make your sensor robust to handle such environmental parameters. Diversity in environmental impacts. Yeah, it's almost whatever I said is the same. Sensing issues will be there when you have environmental issues. When environment goes to the extreme, sensor starts behaving with less accuracy, and then you need to have trouble in getting correlation accurate data. So you need to know how much sensor is deviating for each range of environmental parameter and take care of that drift in the software. Warranty and maintenance. Uh, for IoT system, you need to really jot down the warranty terms very clearly. It should not happen that you end up in selling huge systems to the customers and some warranty terms are missing and you are ending up providing the services more than what you have thought, and at the end it is taking away your profit margin. So product development approach, I think all the past slides I have given you all the points about this product development approach. In this slide I will summarize the step-by-step sequence of product development approach. Product development is very big topic and this is just an initial process, and until you are ready with the design of your product. Beyond product design, the scope is not taken into this approach. So first, selecting right scope, considering user expectations, pain area, must-haves, all possible constraint, competitor analysis. So here I focus on deriving the requirement for your product perfectly. You need to put enough time rather than hurrying up and entering into the designing of the product. You need to put enough time to think on the requirement aspects, what user will be expecting. You need to interview many users in the market, all possible users into the market from all levels, from operator level, manager level till the senior management level. What are their expectations? Because in the same company, the requirement from your product may vary from user to user. So you need to take care of all hierarchies, what they will be expecting from your product, and you have to collect such requirements from multiple firms and organizations who will be willing to buy your product in future. That's what you think. And from that, you need to really identify which are the real pain areas of the customers which you need to focus, and that becomes your must have. That is your must have. If you cannot derive or if you cannot deliver that feature to your customer, nobody will buy your product. Secondly, you need to also derive some of the requirements which are taking care of the pain areas of the customer, which is not delivered by any of the competitor product. If you are successful in finding such requirement, you can develop a scalable product, you can develop attraction of your product with your customers. But if your customer doesn't find anything new in your product than the competitors which they are using, then nobody is going to try new. As I mentioned already, all the constants need to be deeply thought and considered into the requirement specification in order to take those constants into the design. Competitor analysis really helps because when you do the competitor analysis, features, the challenges, cost, launching locations, available market, all these things will help you to derive your business model, initial business model. So this competitor analysis is very, very important. You need to do that before jotting down the requirement of your product. Derive the product requirement and initial business model. So that's what about product requirement derivation after doing the first point, and then you need to define the initial business model. There is a business model canvas. You need to really enter all the fields of this business model canvas. You need to fill this business model canvas, how you will design your product, what are your key values which you are delivering to your end user, how you will deliver those values, via which particular channels you will deliver those values, and how much investment you will do, how much revenue you will generate, how much profit you will generate, who is your target customer, who is your target market. All these things you need to put down on paper so that you will be increasing your confidence that, oh, you will get success. You are sure then. Also, you need to keep visiting this business model over the entire phase of your product design, because this business model keeps on updating. The more you get into the product design, the more your knowledge get increased, and from that increased knowledge your business model will get more perfect. So you need to keep updating those business model versions the moment you get some new insights. Next point, design and manufacture initial minimal viable product, MVP, or minimum useful demo, MUD. What is the difference between MVP and MUD? When I say MUD, minimum useful demo, that means it's a design of the product with minimal functionality which is sufficient to demo to certain crowd of customer. And minimum viable product is a design which take care of must-haves, customer pain areas, and you can deliver this MVP as a first initial sample and check at customer by doing the pilot project to see whether your MVP is really solving their pain areas. That's, I think, will be the next point. Do the POC, proof of concept, with intended user, firm or industry. Check if your product can handle successfully the pain area of intended user. Here you will find whether your product is successful or you have missed some requirement, what is need to be improved in your product. And this is the initial feedback which you will get with reference to your product. If answer is no, check where you need to improve your design, derive that remaining requirement or derive that upgrade in the requirements and work on those improvements. If the answer is yes, that yes, you are able to successfully solve the pain areas of customer, that's a good news. Now you can scale your product. That means your product is ready, design is ready. You need to find how many customers are there in market, how much product you need to produce, and where and all you will distribute those products, who are your distributors, what will be the initial cost, how much will be the AMC period, how much you will charge extra for AMC if there is any additional service is associated with your product, what will be the charge for that service per month or per year. All these things comes under scaling of the product. That's it, guys. Thanks a lot for your patience, and I hope I have added some new points for you in this webinar, and you would have learned something new from my experience. Thanks a lot, and you can reach me for your queries through Sainath Patil sir,